When you think about it, your furnace is really the circulatory system of your home.
And just like our body's circulatory systems, making sure it works at tip-top shape benefits the body, in this case, the house as a whole.
Today on PowerHouse, we'll show you the basics of how your furnace works.
We'll also review some furnace maintenance basics to keep the air flowing.
Plus, we'll spend a few minutes reviewing some cold weather safety tips and debunking some myths.
All good information for creating your own PowerHouse. It is so cold out there.
You got that right. I'm glad to be inside.
You know, we all enjoy the benefits of a working, efficient furnace, but have you ever stopped to think about just how it works?
You know, now that you mention it, Megan, I have. And that's why today we're going to take a look at some of the technology and functions of a conventional forced air furnace.
Well, let's start with the basic components of the heating system. While there are numerous brands and models on the market, many of them have common components located in roughly the same layout on the unit. So let's start with the system component we may be most familiar with, the thermostat. Whether you have a basic older style dial thermostat, an electronic programmable thermostat, or a fully integrated smart unit wired into your home, the thermostat serves as the communication unit for your furnace. From the most basic to the most complex, they all contain a temperature activated switch that tells the furnace to begin the heating cycle when the air temperature dips below the comfort zone at which you've set it. It also sends a signal to stop the heating cycle once that set temperature has been reached.
Your furnace does several things simultaneously when it receives the signal to start the cycle. The gas valves open, the burners are ignited, and the blower turns on. The burners in your furnace are similar to the burners on a gas grill. They're a set of tubes through which the natural gas enters the furnace and is burned. The flames are initiated and controlled by an igniter, the gas valve, and flame sensors. Depending on the age or model of your unit, you may have a pilot light, a small gas-powered flame that stays constantly lit to ignite the burners on demand, or you may have an electronic ignition system. The flame sensor is a safeguard that shuts off the gas if the burners for some reason do not ignite.
Simultaneously with the burners being lit, air is drawn into the unit through the draft hood with a fan to create a mix of gas and air for combustion. The fan serves to make combustion leaner and more fuel efficient. It then blows the heat from the burners to the heat exchanger, where the circulating air is warmed and exhaust gases are vented out.
The heat exchanger in your furnace is comprised of metal tubes heated by the burners. These may sometimes be referred to as baffles. Various models will have different designs to slow down the air and promote heat transfer to the passing air. This is heated air that will be pumped into your ductwork and registers.
The blower fan is the component that moves air coming into the unit from the cold air return ducts into the heat exchanger. It also forces the heated air throughout the ducts and registers of your home. Most high-efficiency units have a variable speed blower that can self-adjust fan speed during operation. The air filter that you replace periodically on your furnace works in conjunction with the blower, helping to keep the majority of dirt and contaminants from entering the furnace and damaging it or making it less efficient.
One of the most important pieces of your furnace is the flue vent. This connection to the outside carries spent combustion gases out and away from your living space to keep you safe. Periodically inspecting the flue, its seams, and its connection to the furnace will assure heat stays in and gases and exhaust stay out for safe and effective operation of your furnace.
All of these components work together to create the heating cycle. In a forced air furnace, that cycle looks like this. The thermostat sends a signal to the furnace control panel. The gas valves open and natural gas or propane is ignited through the burner. The burners warm the heat exchanger, which in turn warms the incoming air. The blower moves the heated air into the ductwork, distributing it throughout the home. Warm air rises and fills each room, forcing colder, denser air back into the furnace and through the cold air return ducts, feeding air to the furnace to repeat the process.
This is just one illustration of how our particular system works. Whether your heating system is electric, gas, propane, geothermal, or even wood-fired, keeping it well maintained through mechanical and safety inspections, plus routine owner maintenance, will keep you warm and toasty for years to come.
Did you know the two most prolific types of furnaces are powered by natural gas or electricity? In some areas of the country where infrastructure for natural gas is not available, propane or fuel oil-powered furnaces are used. Many factors go into the choice of what type of furnace is best for any individual home, including initial cost, cost to operate, size of the home, efficiency and environmental considerations, and even climate. All right, Pete, there you go. Poor thing. You know how it feels when you're sick and you just don't want to do anything? Well, your furnace and air conditioner can get sluggish also. That's why you should consider getting them a tune-up every year. Tune up your air conditioner in the spring and tune up your furnace in the fall. It may even alert you to potential problems. Oh, you're still sick. You should have gotten a tune-up, Pete.
And that's another quick tip from Alliant Energy's PowerHouse. As homeowners, we all hope that our investments in heating and cooling systems will pay off in a unit that operates efficiently, lasts a long time, and provides optimal comfort for our home and family.
You can help meet that goal through basic routine maintenance and good operation. Remember that comparison to a circulatory system? Taking a few easy steps will keep that circulation in tip-top shape.
We've already talked about several basic components of the furnace itself. Let's look at the three main functions of your home heating system and talk about actions you can take to ensure they're doing the best work for you and your family. Function 1, heat production. Heat production is the process by which fuel is converted to heat. Function 2, heat distribution. Your home's ductwork and registers are the paths to distribute and circulate heat throughout your home. And function 3, heat regulation. Your thermostat is the control that helps you regulate the demand for heat day to day and minute to minute according to your set preferences and needs.
We'll come back to heat production in a minute, but let's first address some basics regarding the other two functions of your heating system. Distribution and circulation of heat in your home can benefit from a few minor tasks and adjustments. First, vacuum registers and return air vents regularly to keep dust and dirt circulation to a minimum. Visually inspect exposed ductwork on your own and tape or repair obvious leaks. Have your ductwork cleaned and inspected professionally every few years. Keep furniture and drapes away from registers to promote better airflow and warming. When it comes to heat regulation, you can definitely simplify your life by adding a clock programmable thermostat. Many people are out of their homes at work for the majority of the day, so there's no need to maintain maximum comfort temperature for an empty house. Programmable thermostats are easy to install and operate. A few tips to get the best results: pick a temperature that's comfortable for you and leave it there. Frequent changes force the system to turn off and on more frequently, leading to greater wear and tear. Set different programs for weekdays versus weekends, since your needs may vary, maximizing comfort and minimizing effort. Program it to reduce temperature when you're out of the house or after you go to bed. Reducing heat production in these 8-hour stretches can save you money on your heating bill. If you have zoned heating, turn the thermostats down or off in rooms that aren't being used.
To produce heat, your furnace needs air, ideally clean air. This is where one of the most basic but most important home maintenance tasks you can complete comes in: changing your furnace's air filter. I'm going to head to the hardware store to give you a few tips about buying filters. Now, furnace filters, they come in a variety of sizes and price points. So before you head to the store, be sure to note the specific size and type of filter required for your furnace. At the store, locate the filter style that you need. Newer, high-efficiency furnaces often require one of these thicker filters designed to drastically reduce the particulate matter entering your furnace and your heated air. Older furnaces may take one of these thinner style filters in the correct size to fit your furnace unit. Prices for the thinner 1-inch style filters can vary widely from about $2 to $20 each. Costs for the thicker filters can range from $8 to almost $50. Now, brands have an impact on cost, as do the filter's Merv Ratings. Merv stands for Minimum Efficiency Reporting Value. Merv ratings run from 1 to 16, signifying the effectiveness of the filter in removing dust and other particles. Lower quality fiberglass filters typically rate about 1 to 4 on the efficiency scale. The preferred Merv rating for home systems is in the 7 to 12 range. Higher Merv values, anywhere between 5 and 16, would be recommended for commercial buildings. Now, too high a Merv rating in your residential system could actually starve your system for air and cause the high efficiency components of your furnace to actually be less efficient. No matter which filter price point you choose, the important thing is to change it every 2 to 3 months. When you do, you should be able to tell how it's performing by what it's collecting, as well as if it's operating efficiently with the system. If you need additional information about filters or other HVAC tips and tricks, be sure to visit PowerHouseTV.com.
Did you know that heating is the largest energy expense in most Midwestern homes? In fact, about 2/3 of your annual energy bill goes to heat your home. No wonder parents everywhere tell kids to shut the front door, and the back door too. How do you choose the right LED light bulb for your house? Lucky for you, they have a nifty little label on every box. It's kind of like a nutrition label. It'll tell you everything you need to know. The brightness of the bulb is measured in lumens. For example, 800 lumens is equal to the brightness of a 60-watt incandescent bulb. It'll also tell you how much the bulb might cost you in a year and how long it's likely to last. It'll give you an idea of its light appearance, ranging from a warm yellowish tint to a bright bluish daylight color.
Have you ever installed an LED light bulb and been disappointed how it lit up your room? Chances are you didn't pay attention to the color temperature on the label. LED bulbs come in all different styles, and color temperature is one of the characteristics that changes from bulb to bulb. Let me show you. On the label of the bulb, you'll see a reference to color temperature. It can range anywhere from 2000 Kelvin to 6500 Kelvin. Now, here's what that difference looks like. This is a bulb with the color temperature near the bottom of the range, 2000 Kelvin. You can see how it's more of a yellowish light, very similar to the old style incandescent bulbs. Now here's a bulb near the upper range, 6500 Kelvin. You can see it looks whiter. That's because it's closer to being more like daylight. So understanding the color temperature is really important when it comes to setting that right mood in your home. And that's another PowerHouse quick tip.
A properly maintained gas furnace system is safe and efficient. It uses natural gas, which is a colorless, odorless fuel that comes from the earth. More than 2 million miles of underground natural gas pipelines in the U.S. safely transmit fuel to homes and businesses across the country.
Once the gas reaches your community, the local distribution company adds an odorant to help detect leaks. This rotten egg smell may be your first sign there is an issue with a pipe or a system.
While rare, sometimes problems with gas lines or mechanical systems do occur, and they can be dangerous, possibly resulting in fire, explosion, injury, or even death. If you suspect a leak, immediately leave the area and from a safe distance, call 1-800-Alliant.
While the odor added to natural gas is one sign of a leak, there can be others. Be cautious if you notice blowing dirt, bubbling water, or discolored vegetation in an otherwise green area. Hissing or whistling sounds near a gas appliance, meter, or pipeline are also signs of trouble. If you see any of these, move a safe distance away and call Alliant Energy. If you're not familiar with the odor of rotten eggs, you can contact Alliant Energy for a free scratch and sniff card. The better you know what you're smelling for, the safer you'll be.
While noses are a great early warning device, don't rely on your sense of smell alone. Natural gas detectors are available at most home improvement stores and can provide additional peace of mind. Other overpowering smells, prolonged exposure, or certain soil or pipe conditions can mask the odor your nose should be detecting. Make sure your detector has an Underwriter Laboratories Standard 2034 UL stamp.
To operate efficiently, natural gas equipment requires air for safe combustion and venting. In the winter, snow and ice can damage natural gas meters and block exhaust vents for appliances like furnaces and water heaters. Vents on the roof or side of a building must be clear to allow proper venting and prevent carbon monoxide from building up.
After any major storm, take a few minutes to check your gas meter. Carefully remove snow or debris using your hands or a broom. Kicking or using a shovel could cause damage. Remove icicles hanging from the roof or eaves above the meter. Don't let dripping water or freezing rain build up on the meter. Vents become plugged when ice and snow melt during the day and refreeze at night. Don't pile snow on or near the meter when shoveling or using a snowblower.
One more way to keep you and your family safe is to know the signs of carbon monoxide poisoning and how to reduce your risk. Ideally, natural gas burns completely and efficiently, mixing with oxygen to produce harmless carbon dioxide and water vapor. But certain conditions can result in incomplete combustion and carbon monoxide is released. Improper ventilation, restricted oxygen flow, incorrect installation, or usage of gas appliances can result in carbon monoxide being released. Symptoms of carbon monoxide exposure include headache, nausea or vomiting, dizziness or disorientation, muscle weakness or fatigue, and difficulty waking up. These symptoms can be similar to the flu, but with no fever. If your whole family feels ill or symptoms disappear when you leave your house, you could have a carbon monoxide problem. Have a professional check your appliances right away. Having carbon monoxide detectors on every level of your home can also help you detect and avoid carbon monoxide tragedies.
It can be difficult to think about, but we want you to be in the know. A few simple safety measures and the assistance of a couple of detectors can help protect your family all year long. Did you know gas pipes should be properly maintained within the home and never used for unintended purposes like hanging clothes? This could cause wear or an accidental disconnection. Stay smart, stay safe. Insulation plays a big role in keeping your home comfortable. Heat always flows from warmer to cooler areas. Insulation helps stop this flow and keeps warm areas warm in the winter and cool areas cool in the summer. Insulation's ability to stop the change in temperature is called R value. That is the measure of the insulation's resistance to heat flow. According to Energy Star, the recommended level for most attics is to have an R value of 38, or about 10 to 14 inches of insulation. The easiest way to determine if you have enough insulation is to just stick your head in the attic and look. If you can see the ceiling joists in between the insulation, then you probably will need to add more. Otherwise, it's as simple as using a measuring tape and seeing how deep the insulation is. A properly insulated home could save you nearly 15% on your annual heating and cooling bill and turn your house into a powerhouse.
Here you go.
Hey, thank you.
What are you doing?
I'm just making a list of furnace considerations, things to do.
For me to do?
For us to do together.
Oh, I was in the back bedroom closing down registers. You know, it's a room that doesn't get a lot of company, and I know a lot of people shut down these registers to save money on heating the room.
Well, there are a lot of tips out there on how to save money on your heating bill, and some of those tips are true, while others are more myth, right? So, here's the first one. The bigger my furnace is, the more effective it will be at heating my home. What do you think?
That seems like that could be right.
It's actually a myth. There are lots of considerations that go into selecting the size of your heating unit. You've got the size of your home, the layout, the quality of materials and insulation, and also the design of the ductwork. If the unit is too big based on these considerations, it will short cycle. That is, turn on and off repeatedly, causing constant wear and tear and eventual breakdown. So your heating contractor should help you properly size a system for your specific home.
And that makes sense.
Okay, next. And you just did this. I will save money by closing the vents and registers in unused rooms, which is what you were just doing.
Right. Now, I know a lot of homeowners are guilty of this one.
Yes, absolutely. And it goes back to our first myth on the size of your heating system. With a system properly sized to condition the air in all of your home, closing off vents actually causes additional pressure to build up within your system. And this can cause leaks not only in your system, but also in your wallet. You end up wasting energy and money. So keep those vents open. It helps the system evenly heat your home.
And we learn something new every day.
Yes. Okay, I got one last one. I should get periodic heating system tune-ups even if my furnace is working fine.
That's definitely true. And you know why?
I have a feeling you're going to tell me.
I am. Furnaces are complex systems. Seasonal maintenance and care by an HVAC professional will help increase efficiency in your system, prevent future breakdowns, and even extend the life of your system for years to come.
That's absolutely right, Pete. Some service companies will even give you a package deal on seasonal tune-ups and discounts on service if you sign up.
Now, if you'll excuse me, I have a few registers I need to make sure are open.
All right, I'll check it off my list. Well, we hope you enjoyed this special furnace-centered edition of PowerHouse.
We explored how a gas-powered forced air furnace turns air and fuel into coziness.
We covered key maintenance tips and helped you select the perfect air filter.
A few safety tips were shared along the way.
And we shattered a few myths that could have actually ended up costing you money.
I'm especially glad about that part, Megan. And we hope you are too. Visit PowerHouseTV.com for additional tips and information on heating systems and other features to help make your house a powerhouse.